And please also note that if you have any questions during the presentation, please feel free to use the chat function. And then at the end of the webinar, we'll have a Q&A session and we'll try to answer all your questions the best way we can. Okay, all right, let me start then. So, can you see the PowerPoint presentation? Yes. Okay, I don't hear anything else, so I guess it's working. So the topic of today's webinar is developing the tools for BIM-based circularity assessment. And the name of the project is Circular EcoBIM. We'll start with an introduction. We prepared something special for you, a video that summarizes the main points of the project and that we would like to show you. And then we'll go a bit deeper into the description of the theoretical framework and also the first practical developments of the different platform tools. And in the end, as I mentioned, we'll have a Q&A with the audience. So of course, now a lot of people are showing up, but yeah, that's nice. Okay. So the goal and scope of the project is to enable a circular construction model with BIM-based tools and to promote a circular construction sector. The consortium of the project consists of 6 entities. I'm sorry, I think someone of you has the mic on, not anymore. Okay. Yes, so we are 6 entities working on the project, and the project is mainly funded by EEA Grants. That stands for Iceland, Liechtenstein, and Norway grants. Here you can see the logos of the 6 partner entities. I work for 3 drivers. It's a circular economy consultancy in Lisbon. Another partner is Central BIM. It's a BIM service company. We have big properties. It's a real estate developer in Portugal. And we're also collaborating with 2 universities. That's Instituto Superior Técnico in Lisbon, the technical university, and NTNU, the Norwegian University of Science and Technology. And we also have an architectural partner, an architectural office based in Lisbon that helps us with the development of the platform. Just to give you an idea of where we're at and what are the different components of the project. So the project started in August 2020, and it will end at the end of October 2022. So this year, we have 5 activities. The first one is the theoretical description or the specifications of the platform. Activity 2 and 3 are the development of the database and the platform. Activity 4 is the demonstration phase using case studies. And activity 5 is the dissemination and exploitation phase. So we are now here. Activity 1 is basically completed. The other ones are still under development. So I would like to show you for the first time a video that we've been working on that summarizes the project. I hope it works. It's always a bit exciting with the technology nowadays, but let me try to make that work for you. Just a second. One moment, please. Okay. No. And please let me know if you don't hear the sound, huh? Then we'll try to do it again. Okay. I hope you can see the video player. I'll now press play. Please interrupt me if it doesn't work.
Every year, an equivalent of 18.5% of the mass of Mount Everest is extracted to be used as building materials. Construction requires concrete, the most consumed man-made material on the planet. Cement is the glue of concrete, and its industry is the 3rd largest industrial energy consumer. Worldwide, building construction and operations are responsible for most of the energy use. But what if we could reduce CO2 emissions from the construction sector by cutting the amount of energy use in building construction and operations? What if we could predict the amount of virgin materials needed before they enter the life cycle of buildings? In this vision, architects, civil engineers, real estate developers and building managers could apply circular economy principles and digitalization to analyze material flows throughout the life cycle of buildings and find opportunities to reduce waste by reusing and recycling materials. The Circular EcoBIM project aims to enable a circular construction model through Building Information Modeling, or BIM. The Circular EcoBIM platform integrates BIM tools with the principles of circular economy and the new sustainability framework for buildings called Levels Framework from the European Commission. The Circular EcoBIM platform consists of different components for building analysis. Plugins for existing BIM software to calculate the circularity and perform a life cycle assessment, a digital twin application, and a database. The platform is demonstrated through a case study provided by Vic Properties, one of our partners. The Herdade do Pinheirinho, a real estate development located in the Alentejo region of Portugal. The site is 200 hectares big, 197,000 square meters of holiday villas and other infrastructure will be built. The Circular EcoBIM team used laser scanning to create BIM models of the land of Pinheirinho and 3D technology to model the future villas. The goal is to maintain and use these models throughout all building life phases. The BIM models allow the extraction of material quantities and constructive environmental characteristics of products and materials. This information is the basis for a circularity assessment and life cycle analysis. These improve the understanding of a building's environmental performance. The two plugins for calculating circularity and life cycle assessment are being developed for Autodesk's Revit BIM software. The Circularity plugin analyzes the circular potential for construction and renovation of a building. It allows 3D visualization in the BIM model per construction element. It generates a circularity report indicating the origin of the material and potential end-of-life strategy. The Life Cycle Assessment plugin uses environmental indicators from the database and the building geometry from the Revit model to analyze the impacts of a construction or renovation project. It allows different types of sustainability analysis with a varying range of indicators, depending on the project and user needs. An economic analysis is part of the plugin, which calculates the life cycle cost of the BIM model. A digital twin application visualizes the circularity of materials, use of potentially recoverable materials, and increase of sustainability measures in a realistic building model. The digital twin application also analyzes the circularity potential during the building's use phase. It enables different user function, including 3D navigation, highlighting the illustration of impacts related to different construction elements through a color scheme. Circular EcoBIM aims to help architects, civil engineers, real estate developers and building managers to uncover opportunities to redirect material flows from linear to circular, as well as making early assessments of potential environmental impacts associated to new building and renovation projects, effectively cutting the amount of energy use in building construction operations. And in doing so, reducing CO2 emissions from the construction sector.
So, yes, this was the video. I hope you enjoyed it. We'll go back to the presentation now. So I would like to give you a couple of additional pieces of information that I think are helpful to understand the following presentations. So one of these is a bit better understanding of the levels framework, which was also already mentioned in the video. So the levels framework is a framework by the European Commission on Sustainable Buildings. And one of the big features of this framework is that they divide into building levels. So as the name suggests, level 1, 2, and 3. And level 1 is the conceptual design phase of the building project, which is the simplest level. Then level 2 is the detailed design and construction phase, where you already have a better idea and can quantitatively assess the design performance of the building and also monitor the construction phase. And then level 3 is when the building is completed and in use. And then, of course, you have all the details available, and you can monitor and survey activities while the building is in use. And the distinction between these 3 levels is important for the different tools that are part of the platform. But we'll talk about this more in a bit. So here again, an overview of the platform. So you have different components, you have the database, and you have the 2 plugins, one for LCA and one for circularity assessment, and you have a digital twin application. And we're going to focus on these 4 tools of the platform in the upcoming presentations. So I'm going to start by telling you more about the database. Then I'll hand over to my colleague, Joana Fernandes, who is a PhD student at IST in Lisbon. She will tell you more about the circularity plugin. Then her colleague, Teresa Ferreira, also a PhD student at IST, will tell you more about the LCA plugin. And then our colleague, Rui Barata, who is a BIM expert, will tell you more about the digital twin application. And as you can see here, the digital twin application is for level 3, and the 2 plugins are for levels 1 and 2, as described just before, referring to the 3 different levels of the levels framework. Okay, but let's have a better look at the database. So that the database that we are building for the Circular EcoBIM project is a relational database, and we are following the methodology which you would typically use to assemble such a relational database. So that starts by defining the objective of the database, which in our case is, of course, to provide the information for all the different parameters that are needed in the different tools, so that are needed in the circularity plugin, in the LCA plugin, and in the digital twin application. Then, based on that, we can identify entities, and entity would be basically a table that consists of different parameters. Then we identify the parameters, which are also called attributes of each entity. And then we map the relationships between the entities and attributes. And we write that down in an entity relationship diagram, which is basically showing the structure of the database. I'm going to try to explain you this entity relationship diagram on the next slides also, and I hope it's possible to understand because it's quite a complex thing that involves a lot of information. But yeah, so basically that's the skeleton of the database or the structure, and then of course we have to fill it with information. For this purpose, we have to identify data sources and compile the data, and then we can implement the database. So right now we have identified or described the entity relationship diagram and also identified most of the data sources. However, as the project is still ongoing, we're also still developing this further and collecting more information for specific parameters and extending, if needed, the parameter list. So on the next slide, you can see an overview of the most relevant parameters, which are needed to define the objective of the database. You can see that in this column, and then here you can see that there are different groups. So what's important to understand is that we are collecting information about construction products. And what we mean by that is a construction product could be a material or already a pre-assembled product that consists of multiple materials and that you could buy on the market. So this can be a bag of cement, or it can be a brick, or it can also be a pre-assembled facade element, for example. And because of that, of course, we need to classify and categorize where this type of product can be used in the building, that then later on the database can be used in an optimized way to serve or to provide information for the different plugins. And for that, we need to know, where the type of product can be used. Then we also collect metadata. So where does the data come from that we are feeding into the database? Regarding the environmental indicators which we are collecting, we note down what's the life cycle impact assessment method and so on. We also look up market prices of the different products by checking online what's the market value of product retailers for different types of products. And if a product consists of multiple materials, we note down the different materials that it consists of. On the next slide, you can see all this big list of environmental indicators. So we have global warming potential, of course, it's very well known, but we also collect all the other ones that are typically found in an environmental product declaration. Most of them are needed for the LCA. Some of them, like components for reuse or materials for recycling, are needed also for the circularity assessment. And we collect all of this per life cycle stage. So we have, for example, global warming potential for the extraction of raw materials and for the construction phase and the end of life phase. So here you can see an overview of the entity relationship diagram. Each table is an entity, and as you can see, we have a lot of them. So there's a lot of information that's being collected. I'm going to try to zoom in on them now to explain you a bit better what's happening here. So this, I would say, is the heart of the database. It's the products table. So here the name of the product is denoted, the manufacturer that produces the product in case the data is product specific. We have a Uniclass code. So Uniclass is a standardized categorization system in the BIM community. We note that down, and we also note down the declared unit that tells us the other impacts or the other indicators that we'll have in the database are referring to how much of the product. Then this connects to a table called environmental indicators. So here we have all the different environmental indicators. And also we have a table that provides default values for reuse and recycling in case this is not specifically known for a product, which can happen. Not these values are not always expressed. And then we can have a table that for the plugins that can provide this type of information as a default value in case it's not better known for the exact product. Then this information for products is classified into layers, and the layers into building elements. And then the building elements are also used to define archetypes. The archetypes are an interesting feature of the platform because what we're trying to achieve here is not just to improve the circularity of new construction projects, but also of existing buildings. And what can happen then is that if you analyze an historic building, or let's say an older building, you might not have all the information available that's of the material that actually consists in the building. And then you might want to use one of these archetypes to have an estimate of what you're dealing with. And we have tables on the intensity of use. So that expresses the product specific intensity of use compared to the market average. And this kind of also gives a clue about what's the expected lifetime of the product. This is an important parameter for the circularity assessment. And we have a table on maintenance where we collect information on how often and how intensely we need to renovate building elements. And these three tables here then classify the different products into building elements using the levels framework and the brand layers. I have another slide to explain this a bit better. So here you can see that we need levels and the brand layers to define the hierarchy of the building structure. And what we're doing is we're looking only at the shell and then only at the three brand layers: structure, space, plan, and skin. This could be possibly extended to other layers, but that's what we are focusing on. And that includes the foundation, substructure, load-bearing structural frame, non-load-bearing elements, facades, and the roof. Yes, and we're following the structure because we believe in this way it's very useful for building practitioners that also want to follow the new norms and legislation by the European Commission. Okay, this is the last set of tables, and then we're done with the data and it gets a bit more interesting. Here you can see in green tables that provide information about possible end-of-life treatments. So we have information about material recycling and feedstock recycling. So this is the preparation phase and the actual recycling process, and about energy recovery processes. And this is linked to the type of raw materials that the product consists of. And this, of course, also needs to be classified in the level of waste, which occurred at the end of life of a product, and then for which type of material. And also we specifically look at biomaterials, which are interesting because of their stored carbon content and higher heating value. Yes, I hope this was not too confusing, but this creates the basis for the following presentations. I'm going to hand over now to my colleague, Joanna Fernandez, who will tell you more about the circularity plugin. Joanna, do you want me to share the slides, or do you want to share them yourself? Sorry.
Maybe I can share, please.
Of course, of course. Please go ahead.
Hello, everybody. My name is Joana Fernandes, and I'm going to talk to you about the Circularity plugin. So this is the global methodology we have adopted that was already explained in the last webinar. We started by doing a literature review on BIM LCA integration, the design for disassembly, quantification of circularity, and decomposition of a building. Together with the existing standards, namely the new European levels framework that Verena has already mentioned, the EN 15978 of sustainability of construction works, and also the Uniclass classification system that is a classification system for construction elements that we are going to use for circularity assessment. We have been also collecting data, LCI and LCA data, and now we are defining the circularity plugin and validating it and improving through case studies. Our goal is to create the circularity plugin to support decision makers and designers in implementing circularity principles in construction. So starting from the BIM-based plugin, this is the conceptual workflow. This is an overview. So starting from the top left, the design team has a new project. It can be a new building or a refurbishment project. The workflow is exactly the same, except for the existing building, because it is more challenging, as Verena mentioned, because sometimes we don't know which materials does the existing building have, and we cannot destroy it partially to know what is the constructive system. So when we start the project, we create the geometry and we assign this Uniclass code to the construction elements. And if it is an existing building, here in this black rectangle, we assign the constructive characteristics. When we don't know them, we can perform this building automated characterization that is based on archetypes. And this characterization is linked to a building characterization database. How does this work? The archetypes, they are theoretical models that they are based in statistical information that is combined with literature review and some real case studies to test this methodology. So the user starts by asking some questions in order to determine which archetype does the building belong to. The first one is the construction period, then the size class, if it is a single family building or a multi-family building, the roof type, if it is flat or sloped, if it is then an isolated or continuous building, the material of the structure, the exterior finish. And then we get this code that is this archetype code. And with this code, the plugin returns the main constructive information about this type of buildings. I'm going to show you a little video. This is a graphic user interface in ArchiCAD because we started developing this plugin in ArchiCAD and now it is being programmed in C# to be used in Revit. So here it goes. You select the building automated characterization, then you answer these questions I have explained: the period of construction, multifamily, sloped roof, contiguous, the structure material, and also the finish. And then you get this list of materials. And I don't know if somebody has the mic on. Yeah. And here you have on the left the Brent layers that Verena mentioned, together with the constructive elements, and on the right all the materials that characterize these construction elements. you can see these chains on the left, and if there is some construction element that does not match the default value, you can change, as it was shown right now. So this is the output table of the building automated characterization, is what we have seen. And here you have the brand layers, the building, the construction elements, and here all the materials and constructive systems of this type of building. Now, after knowing all the characteristics, creating the geometry and having the BIM model, we need to identify which elements are going to be maintained, demolished, or introduced. In case of a new construction, which elements we are going to create. And also, this is very important to assess circularity. We need to know how these elements are connected between them, how they are assembled. And it is what this red black box says, the disassembly information. So this is, once again, the graphic user interface of the ArchiCAD, and we have to do, the designer has to do this for each construction element to characterize all the connections between these elements. I'm going to show you another video where you can see how this is being developed. So this case is a wall that is highlighted here, and then you open the dialog box, you select DFD, disassembly information, you characterize the connection here. If it is dry with added elements, hard chemical connection, and then you answer some questions that are necessary to calculate circularity. If you know what is the end of life strategy, if it is to be recycled, reused, etc. If it contains recycled or reused components, and further information on the disassembly, what kind of hard chemical connection it is, its accessibility, crossings, the form of containment, if it is closed in several sites, and the elements that are connected to this construction element, like doors, the ceilings, and the floors, for example. Here you have the summary table of the disassembly information, the brand layers on the left, the construction elements, and all the information regarding each one of the construction elements of the project, the adjacent elements and the connection type, accessibility, crossings, and form of containment. We also bring you here some screenshots on the Revit plugin that is being developed in C#. This is the graphic user interface of the archetype selection. This is also the archetype selection with a model on the back. This is already in Revit. And here, that is an innovation. This is the template selection. What is this? These are not archetypes, but the team has decided to create a predefined library of construction elements so that the designer, when he's creating a new building, can choose some predefined walls or ceilings or floors to be easier and faster to assess circularity. And then, of course, you can change or can create from scratch. That's just to facilitate and this process to become faster. Then we start doing the building circularity assessment itself that is connected to the database that Verena has already explained. We are working now on this part, so it is still under development. And what we are going to do is this, analysis in the center, this calculation module that gets information from the BIM model, this information that is extracted from the BIM model and from the database. And the output will be the 3D view of the model with some colors regarding the level of circularity and a report. Sorry. Oh, sorry. This is an example of the graphic user interface. On the left, we can see the BIM model. This is still being tested. In green, there are the more circular elements, and in red, in this case, is a masonry wall. It is a not so circular element. Then we are also working on obtaining this information, the original material, the end of life strategy, all the circularity indicators from the product until the building. And we are also doing this macro level of assessment by calculating the embodied carbon and the embodied energy. So after the circularity assessment, the designer selects the best option. The designer gets this information in real time and can change the project many times as he wants, and can perform this assessment every time he wants, and then detail the BIM model. After detailing the BIM model, the circularity assessment can be performed again and gets the optimized model. I guess that's it. Now my colleague Teresa is going to talk about the LCA plugin. Thank you.
Thank you very much, Joanna. Can you see my screen?
Yes.
Yes.
Thank you. I'm going to present the Levels LCA plugin. As mentioned by Verena and by Joanna, this is based on the Levels framework developed by European Commission. Regarding the LCA plugin, from the 6 macro objectives from Level, the important ones to take into consideration are the first one, greenhouse gas emissions along buildings life cycle, that takes into consideration life cycle global warming potential. The information is analyzed having in consideration the bill of quantities and materials from the BIM model during this lifespan. We will also analyze the macro objective number 6, which is the life cycle cost. The LCA plugin has many functionalities, 6 functionalities in total: Streamline LCA, Complete LCA, Levels LCA, Carbon Footprint, Levels Global Warming Potential, and also Costs for life cycle costs. Each of the analyses has several environmental indicators and economical indicators on the cost analysis that are inserted into our plugin to perform each of the analyses, as you can see in this image. This plugin Levels framework is aligned with the stages of the project where we are. The LCA plugin covers level 1 for conceptual design and level 2 for detailed design and construction. On the level 1, there are questions to be asked to the user. There are yes/no questions. This and a brief description that could be added. On the level 1, couldn't be quantified. We don't have quantified information. On the level 2, we have quantified information for each of the environmental or economic indicators. They are converted into parameters that will be analyzed within our BIM environment. This is the product data template that we have developed, where you can see the indicators per functional analysis, and also the unit of analysis. For example, on the global warming potential, you analyze the CO2 emissions. This is the fluxogram from our plugin. First of all, you need to have a BIM model. Select which is the stage of the project where you are. Level 1 for conceptual design. On the level 1, you have the option to perform levels, life cycle, global warming potential analysis. You do all until the end, and in the end, the user will be asked if you want to go further on the LCA analysis. If yes, jumps to the level 2, where you have many more analyses to perform. If you pick, for example, streamline LCA, you go all the analysis until the end, and if you want to go further on the end analysis, you can come back and do a complete LCA. Complete LCA is the last one, is a more complete one. The same goes to the levels global warming potential. If you do the analysis until the end, you can finish and go back to the streamline LCA. I will now show a video of the LCA plugin working. You go into the Circular EcoBIM tab, pick Levels LCA plugin, then select the analysis. Now Levels Global Warming Potential is selected. You can see the list of indicators used to evaluate the performance. And another option is Levels Lifecycle Assessment. And here it is the list of indicators used to evaluate the performance. Streamline LCA is another option of our functionalities. We will pick Levels LCA and go next. It includes the information in materials or elements that are actually modeled in the BIM model. They are loaded into the plugin, and the indicators or parameters are loaded. Then you select a material and add the information to the material, including the acquisition costs. After that, the information from the material is added to each element and do the final calculations with all the materials that are covered, for example, in a wall. It is also possible to add the information to an element, directly to an element or a product, as mentioned by Verena, or a window, a door, that combines all the information. Then you press next. All the environmental and economic information is now in the project. You can see the types that we have for walls, doors, windows, and also the listed materials, covering all of our environmental indicators and cost indicators. In this project, for example, we have the total of 70 elements. Now, click Run the analysis. These are the analysis results, the total environmental impacts and acquisition costs of materials of the project on the first schedule. And on the second schedule, you have the information detailed by element. You can also see the LCA results and acquisition costs per element. For example, here we are selecting a wall and see the list of all the walls presented in the project. The same can be done for windows, doors, floors, roofs, any other kind of elements. Then you create the views. Select the button to create the views. It is also possible to export the streamlined LCA for an Excel file. We are now creating the views for all the environmental indicators, and we will show in detail ADPM, that stands for abiotic depletion potential of materials. Select the 3D view, and you have a color scheme that represents the impact that it has. We can see the walls here on this example. If it's green, has a less impact. If it goes to red, it has the highest impact on the model. If you pick a wall and go to edit type, you'll see on the type properties the environmental indicators converted into parameters that on the Revit elements, and this contains the actual information and calculations for each indicator. Thank you very much for your attention. I will now hand to my colleague from Central BIM, Rui Barata. Rui, the floor is yours. Thank you very much to all of you.
Thank you very much, Teresa. Thank you very much for all the people that are seeing us. I will share my screen. And hope that everybody is seeing my screen. Verena, can you confirm?
No, not yet. I think maybe you selected the wrong screen. Yes, something is loading.
Yeah.
Okay. Yes, please feel free to start.
So, I'm sorry. So, the goal of Circular EcoBIM project aims all phases of the life cycle of buildings, and we organize our tools that we are developing in two major groups in relation to levels framework. So the level 1 and 2 that are design and build phases facilitate the choice of materials with the greatest potential for circularity, and we have a tool, a Revit plugin tool to, like Teresa mentioned, to make the LCA lifecycle assessment of the building. My goal here and now is to talk about our level 3 application, a level 3 tool. That is, the goal is to the operation phase of the building. And this tool will facilitate the forwarding of materials by choosing the best treatment type for the materials and the treatment entities that can handle them respectively. So Circular EcoBIM is a BIM-based platform that integrates two plugins for Revit. The left side here, we have an external database and a digital twin application. Just a moment. The Revit plugins are level 1 and 2 tools that permit the calculation of circularity and do the LCA assessment. The database stores information about various building life cycle parameters and circularity information of materials, and permits the communication between the Revit plugins and the digital twin. The digital twin, a level 3 tool, like I mentioned, will support building owners and users in the operation of the building. It receives information like these arrows represented here. It receives information from the external database, and we receive the BIM model that were developed in Revit as a digital twin. This digital twin have all the 3D geometry plus the metadata. All the information that we populate in the BIM model, we can access it here in the digital twin. So the digital twin application, generic visualization and interaction features are seeing different disciplines like architecture, structure, mechanical, and plumbing, navigate in any space of the building, interact with the elements and access all the information in terms of materials and geometry, like volume, area, etc. Identify the buildings, the building elements with colors, with the scheme colors that we choose to indicate, for example, the calculated circularity levels or LCA. So a little bit more deeply, the digital twin aims to help users to manage materials from our building in all the operation phase. We can imagine our building being renovated along his life cycle, and there are materials that we have to manage, and what we don't want is to put all the materials like waste in a dump. So the main features, the main functionalities of the digital twin application are we are able to import an as-built digital twin that is a replica of an as-built model that contains all the 3D geometry and the formation of data from existing building elements. We will be able to manage building elements and materials, which helps the facility manager to maintain and register in our external database what is going to happen on our building, and we will have inside our database, we will have a table regarding specifically to manage the treatment entities. So our goal is to create a graphical user interface that must be as simple as possible. So we are using, we are trying to implement the best way to treat the materials that the theory give to us, and we have implemented a color scheme to try to represent in a visual matter this best way to treat materials or elements. So in green we have we will represent the reused materials. This flow chart is a simple way to implement, and what can we do for each element. We should reuse the materials or elements. We should, if we can't reuse, we will recycle, and if we can't recycle, we should recover the materials or some kind of energy that those materials permit us. And if we can't do anything of that, in that way, we will dispose it. We will treat that as a waste. And like this color represents, we don't want that. There is another, the first thing that we will, we can't do much thing on a material that is contaminated. So we represent also as red, in a stronger red. In our application, we will have the possibility to choose treatment entities. That is, and this depends on each region that we are, that our building is. This must be managed for the treatment entities that exists in the proximity of our building, that are interested to treat our materials, and our application will create will have a possibility to create a report. So this is our goal. In this moment, we can tell that our application in this moment we have all the functionalities executed, but we don't have already the graphical user interface as organized as this, but we want this kind of arrangement. We in this moment we have already developed the representation with colors, like this table. We have the possibility also to represent with colors the circularity levels for each element, and we will have graphs that represent with the same colors what are the treatment types for the elements that are going to be out of our building. So giving this, I will just end to show a video again, just to show a little bit more the stage of our application. This like our first video on our presentation. This villa, this house is on the land of Herdade do Pinheirinho, big properties, one of our partners. And I will put play. And this is one of the villas that will be constructed. So we can access in this moment like this video, we can access all the BIM information for every element. We have the possibility to have projects that have different phases. This menu here represents the actual. We can access in this moment the actual. The actual is the land don't have any villa in this moment, any house, but the project is this villa like we are seeing here. But we constructed a model that represents a possible remodelation, a renovation, and this video shows this. This is just for the purpose of our study, of our project, but it permits us already to have these tables with the representation of all elements and materials that and the treatment type for each element, each material, and the finishing of this video is the representation with colors, the different elements regarding the circularity indicator. So thank you very much, and now I will pass to our friend and colleague Rolf, please. Thank you very much.
Hello everybody, and yes, my name is Rolf from NTNU in Norway, and I'm going to try to facilitate some questions. We had a few questions in the chat. First of all, and I guess that is to everybody, kind of from, I'm not trying to pronounce the name in full, but from Arlin. And the surname I can't, sorry, I will not try even. But the question is, will the plugin be available to be used for free in Europe, or at least in research and academia? And can they test it? And when can they test it? So I guess that this was especially for Joanna and Teresa, but I guess this also applies to you, Rui. So kind of, when can people get hands on this?
Regarding the digital twin, I can say that it's going to be free. So every people can access to it. Yeah.
And when will we have it available for the audience?
I think maybe October this year.
Oh.
Yeah.
So we say end of 22. When the project is finished, we will launch all the tools. Okay, yeah. Fantastic. And this, Juana and Teresa, is also true for the LCA and the circular plugin?
Yes, I guess it makes sense that when the project finishes, the circularity plugin will be finished and available. Yes.
Regarding the LCA plugin, once by the end of the project, we will provide the LCA plugin with the functionalities related to the levels framework. So the levels global warming potential and levels LCA, and also the levels for life cycle costs will be freely available.
Excellent. Then we have kind of a question which I think is related to you, Teresa. At least that's what I got from the timing of it. The question is, how do you handling? It is from Erwin Amskau. Hello again, Erwin, long time. Thank you. Very interesting question. How do you handle missing data? e.g., if a building material is missing the EPD?
If the building material is missing from the EPD and we still have the EPD for all the elements, the compiled information for an element, that is not a problem because the plugin either analyzes per element or per material. And even if it is per material, it aggregates all the information in an element. So that is not a problem. If the question is regarding, for example, a type of concrete that it's not available in an APD, we already provide on our database information for generic concrete or the main construction topics. So the database contains the main ones to perform the analysis.
You happy with that, Erwin, or you want to have a follow-up?
No, that's fine. So I understand you use generic where you don't have the EPD. That's fine. Thanks.
Very good. Then there was another question, kind of, I guess this is both to Juana and Teresa, maybe also to Roy. Where do you get the embodied carbon data from? Is it country specific or more average values?
Can I maybe try to answer that?
Of course.
Yes, so the idea is to focus firstly on data from Portugal, to use EPDs from here. However, that the amount of available data is very limited. So then we would look at a wider European context. And if that's also not available, but it's a critical material that's needed, then we would look at EcoInvent data and model the process to additionally feed the database. But until now, the EPDs that we found so far at a European scale, they cover pretty much anything that's necessary. However, then of course you need to keep in mind that things like electricity mix and transportation distance and so on, also manufacturing processes can be different. So yes, it's not perfect, it's an approximation.
Okay, very good. We have a question from Helge. Do you want to ask it yourself, Helge, or should I? Helge Brattebø from NTNU.
I can do it.
Yes.
Thank you. So maybe this question both to Verena and Joanna regarding transferability of the methodology. So when you lack data from specific, let's say, building elements in an existing building that you would like to implement, you rely on the use of archetypes. And each archetype will have to be fed with its data. To what extent do you think such data can be transferred, can be representative across countries, since there are quite large, let's say, building technology traditions and climate?
I might start answering and then Verena, you might help me, please.
Sure.
Well, I guess that those archetypes, they are country specific because we rely on national statistical data and also the literature review on construction techniques. Maybe they can be used in other countries with similar construction methods, but I guess that we can use the methodology, but not transfer all the data. Yes, that's my vision.
Yes, I would also say that maybe you have to separate between the more historic buildings, which I think are very particular or very specific to the Portuguese context. But then also, of course, we make assumptions about wall assemblies and roof assemblies and so on. And the more you approach modern day, when you talk about reinforced concrete and EPS insulation on the outside and all of this, of course, then this is transferable. But I think it would need to be adapted to country specificities. Yes.
Yeah. So that means basically we have to build a, let's say, a library of archetypes that is kind of country specific or region specific.
Yes. Yes. Thank you.
Very good. And please, everybody, if you have questions, post something in the chat. I have a few questions, of course. I have done my homework. I think I will start with Joanna. I have several questions, but one of them was asked, that was about the architects and templates. But what kind of element or construction is best for the circular buildings is kind of a question. And another question is what you see as the next challenges towards kind of a more automated calculations of circularity.
Thank you, Rolf. Starting from the first one, I guess that I cannot give you a straight answer what is the best for circularity, because it depends on several factors, as the use of natural resources, the waste generated, and also how many times some construction element can be reused or if it can be recycled. So talking specifically, for example, the content of recycled material or reused components, they have a huge weight on calculating circularity, but also the disassembly of the several construction elements, because you can have the same construction elements, like the same two walls, and they are assembled in a totally different way. And that influences the end of life options. So I guess that we cannot give a straight answer, and we have to be attentive and pay attention to these three, I guess, main ideas: the recycled content, the possible of reusability, and also the disassembly and the connections between the elements.
Yes.
Yes. Okay.
Thank you.
So now the next challenge, as it is still under development, I don't know if we already know which are all the challenges, but right now our main challenge is to create a graphic user interface that is friendly for the designers to perform circularity with little effort. Otherwise, the designers won't use the plugin because it will need to enter lots of detailed information. So our challenge right now is to have and to create a balance between the information that has to be inserted in the model or by the user and the automatization of the process.
Thank you very much. And also now there's a little side discussion in the chat, because Maud has kind of enlightened us that there is some work going on archetypes among industrial ecology bottom-up structures. And then Helge has replied and kind of that these bottom-up data suffers from the use of different varying classification systems. So maybe Helge, you want to elaborate a little bit on that?
I don't think I need to do it. It's obvious that it's super important to build on previous work regarding developing a library for archetypes.
Yeah.
But just pointing to the fact that you should also be careful in doing that. This is a very important part of the project follow-up work, I guess, in order to make a system usable.
Yes, and it's also, as have been said many times here, very country-specific kind of things. Okay, thank you very much, Joanna. I'm very happy with the answers, and please kind of keep using the chat. Teresa. I have a question for you also. How things are developing, and how well will this model and this plugin keep expanding when to either future standards or more indicators? So if he suddenly wants another indicator, how well can this system of yours adapt?
Thank you very much for your question, Rolf. Nowadays, the plugin is constructed based on the European standards, the levels framework, and also the standards EN. But its coding, its programming was built in a way that it can easily expand, and new functionalities can be added, as well as new parameters of analysis that might arise in the future, and also remove parameters that are made redundant in the future. So it can easily grow. In the programmatic sense, it will be easy to keep growing or remove.
And in this way, a follow-up question would be kind of linked to what we were asked further when, if this is made available, will this then be kind of an open source thing, or do you want to keep control of it, or how will this be kept alive? Because yeah.
We will keep, hopefully in IST, we will keep developing the platform beyond the life of this project. It will be definitely make available the levels framework part of it. So the levels global warming potential and levels LCA will definitely be available for public use.
And if you were going to use and have to focus on one indicator, what kind of indicator would that be? Kind of currently, at least.
Currently, the most important indicator is global warming potential that analyzes the CO2 emissions. Mm. So if you have to pick one functionality of the plugin, it's definitely the levels global warming potential that will be picked. Mm. And it's focused on the emissions from the CO2 emissions. It's only has one environmental indicator divided in 4 parts for fossil, biogenic, and land use. So it's this one.
Okay, we have another question in the chat. It's from Pedro. And his question is the external database ready to receive data templates from several origins?
Yeah, I'm not sure I completely understand, but let me try to answer. So we have a product data template with specific parameters that need to be provided for each product, and this we fill out and then feed the database. So yes, you need to kind of follow this type of parameter structure. So I'm not sure if it comes from a different origin. It might be that it has a different structure, but maybe you can transform it. If you cannot transform it, then the answer would be no, you cannot use it. You're muted, Rolf.
Sorry, yeah, it was too much. Sorry, are you happy with that answer, Pedro, or do you want to have a follow-up?
Oh yes, I'm happy. I think I will follow up after. Thank you for the presentation.
Very good. So then Helge has another question. Maybe you will just take it yourself.
Of course, when we estimate potential for circularity and impacts related to options, we have a model, and we're always concerned about how robust are the results. How do we relate to uncertainty and sensitivity in calculations and so on? Maybe this is something that you have thought about how to relate to, or do you just think of doing a sensitivity by varying, let's say, parameters one by one?
Yes, from circularity, we are trying to varying parameters one by one. That's how we are doing it right now, but we are still under development.
I think that was the question. I don't have more questions in the chat, and Helge didn't. Yeah, so I trust you are happy, Helge. Then I have a question for Rui. We haven't forgotten you, although there are many questions for the others. I'm kind of curious, what is the added value of the digital twins in comparison with both the circular and the LCA add-ons? Kind of, why do we need the third one, the digital twin?
Yes. We have to think that the plugins are in different phases of the digital twin application. The digital twin application is for the operation phase of the building. When we are talking about Revit plugins, the circularity calculation and LCA assessment, we are talking about project development, the construction phase of the building. But when we are talking about operation phase, the users that will continue to use the BIM model are completely different from the two phases, the two previous phases, project, design, and build phases. So we have to think that in the previous phases, design and build, we have architects, engineers, consultants that they use Revit, Autodesk Revit, very easily. In the operation phase, the normal user don't have the knowledge even to use this kind of tool, and we have to think about operation. It's all about maintenance, security management. There are lots of functionalities besides what we are developing here, besides what we are talking here, but have some kind of connection. So the goal is in the future to receive information about those systems and connect to the systems that are in the building, use that information, and with the functionalities that we are providing here in our tool, digital twin application, we will use all these informations and correlate them and create more elevated information. So.
And do you also in the future see that all this can merge together kind of as a tool for what you can call urban mining, or? Completely.
So we have to think that one presentation that I saw in previous webinars or something was we can see buildings as mining sources. So if we have an application that permits us to track the materials, what kind of materials that we put in the buildings, and what kind of materials, and the moment that we extract the materials from the buildings, we can use in a more efficient manner and predict what kind of materials will be available in different moments of the life cycle of the building.
Very well. I'm running out of questions. The chat is has no more questions, and I think we are also running out of time, Lorena. So
yes, I think that's it.
I give the word to you to close.
Yes, yeah, thank you, Helge. I can also give that back. Thank you to our partners from NTNU. I think above all, the project is a nice opportunity for us to strengthen the relationships between the different research and corporate entities in Norway and Portugal. This is still under development, so please stay tuned. There will be a final event, probably in September. I hope you will join again. And thank you so much. It was really nice to see so many people, or at least so many names here. And have a nice afternoon, and until next time. Thank you. Goodbye.
Thank you very much, all.
Thank you. Bye.
Thank you. Bye-bye.